All right, hello Year 12s. We'll make another video for Introduction to Continuous Random Variables. This is looking at example 2 on page 586. Bit of a dry example, not much of a story here. It's not looking at, measuring some measurement, the height of a person. It's just looking at the raw mathematics of it all. And they've given us a function here. It looks like a piecewise function, and it is. It's a piecewise function, but we're going to break it down. Basically, what we're looking at is for these values in between 0 and 1, so on your x-axis, in between 0 and 1, your function's going to look like this, right? Quadratic. It's going to look like a quadratic. And then basically everywhere else, so when x is larger than 1 and when x is less than 0, you just got a flat line. You just got nothing, right? So it's fairly straightforward here. Part A, so given this function here, sketch the graph, right? So let's go ahead and sketch this graph. First of all, I'm going to go ahead and write the function down that I'm mostly going to have to work with, which is this part here and this part here. So part A, I'll just start working here. So we'll go with f of x equals 1.5, 1 minus x squared, if 0, x, and 1. Okay. Now, I know this is a quadratic because the highest power is 2, but we got some nasty brackets here. I'm just going to get rid of the brackets, right? And we're going to put the highest term, which is the x squared term, at the start. So let's go ahead and do that. We'll expand by multiplying out using the distributive law. So 1.5 times 1 will be 1.5. And 1.5 times negative x squared will be negative 1.5 x squared. So negative 1.5 x squared, add 1.5. So just by inspection, I already know a couple of things. Number one, our graph is negative because we can see a negative sign here. So I'm just going to write a couple of things. Negative. And we also know that the y-intercept is currently sitting at 1.5 because that's our c value, our number or constant on the end. So y-intercept equals 1.5. Okay. So we have a y-intercept. We know it's negative, so it's going to look, like that, not like that. The last thing we would really need to start making this shape is the x-intercepts, right? And how do we find the x-intercepts for a quadratic? Well, generally we use the quadratic formula or factorize, but as you can see here, we don't have a b value, so we can go ahead and just, simply solve here, just through some basic arithmetic or rearranging. So let's go ahead and we'll write, we're going to find the x-intercepts. Generally do this when we let y equal to 0, right? So when we go ahead and do that, we get this. I think I'm going to need more space now. In fact, I could zoom in and, I don't want to be crammed up. So let's go up here. All right, so 0 equals negative 1.5 x squared plus 1.5. So again, we're trying to find the x-intercepts. All right, next is we'll take across 1.5 by subtracting on both sides. So negative 1.5 equals negative 1.5 x squared. Dividing by negative 1.5 on both sides to get rid of this, we divide. And that'll give us, negative 1.5 divided by negative 1.5, because this will go across to here. This will become 1. So 1 equals x squared. So x must be the square root of 1, which is either negative 1 or positive 1. Right? So now we have two solutions. Okay. Let's go ahead and attempt to graph. We pretty much have all the information that we need. I'm going to go ahead. I just know that I'm going to have a bit of trouble with space here, so I'm just going to go ahead And resize this a little bit. And I'll attempt to graph over here. Now watch me as I do this. What you're going to notice is that when our x value is less than 0, right? So basically all of this here, when it's less than 0, our function is at 0. So it's just a straight line going across here. Can you see that? So here will be 0. And where's the other part where it'll be 0? When x is larger than 1. So let's pretend that this is 1 here, or let's go a little bit larger. Let's make that 1. And so basically that line there after 1 will be 0, and then anything less than 0 will also be 0. And so we're only going to have this bit corresponding to whatever is in between this region. So we're not sure what it's going to look like, but we do know a couple of things. Number one, the y-intercept is at 1.5. So let's start kind of readjusting this graph. First of all, I don't need anywhere near as much space on this side or this side. So we can just adjust this now. Put some arrows, right? And what's going to be on the x-axis? Well, that's x. The y-axis will be y, or f of x. And we'll put some numbers down. Let's say this can be our y-intercept, so 1.5, which would make this 1, and that would be 0.5, and so that's 0.5, and that's 1. There. All right, so we've just kind of done our graph up, and now we're going to go ahead and attempt to put some information in. So our y-intercept is 1.5, as already previously determined, just by inspection here. And with some arithmetic, we know that our roots, or our x-intercepts, are at 1 and -1. But again, we're not interested in the -1 because we already know our line is across the 0. Okay, so we're just interested in this part here. So there's an x-intercept there. Right there. Right, knowing the nature of this graph being a quadratic that's negative, we're just going to go ahead and attempt to just draw it. So let's just go ahead and draw it. All right, first time's a charm. Here we go. Whew, this is tough. Bit wonky, but you can see that I've done the trick here. All right. So it's like an upside down portion of the quadratic here, making a parabolic shape. So now we can see that we've already covered this part of the function, right? In between 0 and 1, we've got that shape, okay? Done. But now we just need to consider the idea that we've got to take care of this part here, okay? So basically anything greater than 1 is a 0, and anything less than 0 is also a 0. And we're going to use a nice thick line to show the reader that we know this. So, straight line, 0, and 0. Now let's just keep in mind that at x is 0, right? At this point right here, we would put a circle here, but not actually fill it in. Let's use a real thin stylus. We're not going to fill it in, but here at the top we do fill it in, right? Why would that be the case? Well, because anything less than 0, right? Less than 0 is 0, but if it is 0, right? Can you see how there's an equal sign here? It is included, so we color it in. Right, we color it in with green here, and we leave it out here because at 0, it's just nothing. All right, so that's our graph. Looks like that. Okay, Part B. Show that f is a probability density function. Well, the way that we do that is by using a rule, but it's this idea that if we went ahead and found the probability, so we integrated for this entire function, we would get a probability of 1. That is, for this entire function, if we integrated in between 0 and 1 for this function, we would get an area of 1. I hope that's the case. Otherwise, this is not a probability density function. Let's go ahead and just make sure that's the case then, right? So what rule do we use? Well, we use this rule. Rule number 2 is going to help us with this question. As long as we integrate for this entire function, right, we get an answer of 1, that means this is a probability density function. And we can move on to the next question. Okay, so part B, let's just go ahead and write that we're doing part B here. I'll put a straight line across. I think I need a bit of a thicker stylus there. There we go, that's nicer. All right, part B, we write this. Integrating between negative infinity and infinity for this function, right? From the smallest value to the largest value that we can for our function with respect to x, it should give us 1. So I'm going to go ahead and work down all the way, integrating our smallest value with our largest value, and hopefully we'll get an answer of 1, which will prove our original rule here. So let's go ahead and do it. Our values, our smallest and largest that we could possibly do, will be between 0 and 1. So let's do that. So integrating, let's use a little bit less space. Between 0 and 1, we're going to write the function. Okay. So 1.5 multiplied by 1 minus x squared with respect to x. And we'll let that equal to 1. But now for the rest of this, I'm not going to write equals 1 now. I'm just going to keep working down. So let's go ahead and do this. So we'll go ahead and leave our coefficient out the front. And now we're going to go ahead and integrate. So the integral of 1 is just x. Take away the integral of x squared. Remember the power goes up by 1, and then we divide by that power. So we're now going to have x cubed on 3. And then we're going to integrate that with our terminals being 0 and 1, right? 0 being our smallest value as defined by the function, and 1 being our largest value. Okay. Okay, keep going. We're now going to substitute 1 into our variables, take away what happens when we put 0 into our variables. So it'll look like this, 1.5 times, ready, big brackets and small brackets, 1 minus a third, minus, now 0 is going in here now, so it'll be 0 minus no thirds at all. From here, we'll get 1.5 multiplied by, and you can see that 1 minus a third is 2/3, right? If you have 3/3, take away 1/3, you get 2/3. This is 0, so it's 1.5 times 2/3. Now this here is basically 3 halves. 1.5 is 3 halves, so 3 halves times 2/3 will be 6 over 6, which is 1. So we've proven that this particular function is a probability density function, right? The total probability for this entire event for all possible x values is just 1. That's exactly what we set out to do, and we've proved it. All right, we're going to move to part C now. Now I am running out of space here, so I'm going to go ahead and make a new page, and I'll copy the question here. So part C is this. Find the probability that our x value, or our probability, our random variable is larger than 0.5. So I'll say that again. Find the probability that our random variable is larger than 0.5, where the random variable x has a probability density function f. Okay, so what we're asking then is, for our x value to be larger than 0.5, that's this here, ready? I'll use a different color now. I'll use, say, orange. We're really asking this question. What's the probability of success, right? Or the probability of interest in this region here between 0.5 and then the largest value. Because remember, I was asking this, the probability that x, right, is greater than 0.5. Okay, so we go ahead and actually find it. So we're just integrating then between 0.5 and 1. Fairly straightforward, hey? So let's go ahead and do it. So we're finding the probability that our x is larger than 0.5, which is equal to the integral, the definite integral, between 0.5 and 1 for that same function that we used previously. Yeah? So let's keep going. We'll go ahead and do this. Keep our coefficient out the front. We'll integrate, which we already know it off by heart. It's x cubed on 3 in between 0.5 and 1. So we're now going to start substituting. So we'll get 1.5 times, big brackets. Now this is going to be 1 minus a third. We already know this. And we're going to take away what happens when we put 0.5 in. A little bit different this time. Take away, this will be 0.5 on 3 cubed, square brackets. And then what you'll get is this. So 1.5 times 2/3, which we know this is 1 here from our previous question. But from 1, we're going to be subtracting, well, hold on. That's not mathematically correct because we still need to use our square brackets, right? So it's going to change it up a little bit, in fact. So 2/3 take away, and now we're going to have 0.5 take away. Now 0.5 times 0.5 times 0.5 is 0.125. We're dividing that by 3, of course. And if you put that all into a calculator from there, you'll get, and this is the probability of our random variable being larger than 0.5, it's 0.3125. So it's roughly a third. There's a third of a chance that our probability, or that our random variable, will fall in this region here. And that's our example. Thanks for watching. See ya.